This episode of On Orbit is brought to you by Swissto12, a manufacturer of advanced satellite radio frequency components, payloads, and systems. Emile de Rijk started Swissto12 with a simple goal: to make access to GEO faster and more affordable. In order to achieve that, the company had to think smaller. From its origins as a startup, Swissto12 is now coming of age as a disruptive European satellite manufacturer. This week, Emile joins On Orbit to talk about the company's cutting-edge payload technology and the decision trade-offs that come with payload flexibility. We also talk about how Swissto12's approach to smaller, more flexible GEO satellites fits in with the current focus on sovereign space and how it might also fit into future concepts of orbital data centers. The company's at a critical juncture this year, with satellite builds for both SES and Viasat, and Emile gives the latest updates on the Hummingsat program. I'm Rachel Jewett, and you're listening to On Orbit, the podcast that asks, what's our future in space? Hi, Emile. Thanks for joining On Orbit. Excited to have you on the show. To kick us off, I kind of want to go talk a little bit about your vision when you started Swissto12. So Swissto12 is one of the leaders in small GEO, and the company has disrupted the traditional approach to geostationary orbit with smaller, cheaper, more flexible satellites. In the early days of the company, what made it clear to you that GEO was ready for disruption?
So at the core of the company is advanced payload technology and associated products. So Swissto12 has been very engaged with satellite manufacturers and telecom operators across various orbits to develop and deliver the most advanced payloads to meet challenging mission requirements and business cases. And through that journey, we obviously over time got in touch with that ecosystem, and in particular the satellite operators with whom we had a lot of conversations. And over those conversations, gradually realized that their businesses have historically been heavily relying on GEO, but the GEO market is changing very fast. So it's a market that is shifting from what was predominantly a broadcast business model driven market to a market with declining broadcast segment, a growing broadband connectivity segment, but a broadband connectivity segment that is also getting addressed by non-GSO and GSO constellations. And so market dynamics that are very different now for operators in the sense that it becomes increasingly hard to predict where future revenue will come from. There is a clear realization that there's a lot of growth and the sector is booming, but it's harder to exactly know years and years in advance where this will come from. And if you combine this with the fact that the traditional GEO product offering has long been based on a very large, very optimized satellites that have exquisite capabilities, but that are relatively costly and slow to build, that did not match well with a lot of the business cases that required faster response and iteration and a more incremental approach to deploy capabilities in orbit. And so that's really what led us to the realization that there is a need for disruption in GEO because there is demand, but the product portfolio that is being offered does not fully meet that demand. And so, yeah, Hummingsat kicked off that way. The mission statement was pretty simple, make it faster, make it more affordable, and hence make it smaller. And that's what we've embarked on as a journey to deliver satellites to some of the most renowned global satellite operators who we were privileged to get as our initial customers.
Yeah, so you're building Hummingsat satellites for both SES and Viasat, and you said that some of the vision for Hummingsat came from those early discussions with satellite operators. How were you able to gain their trust and get them to come on board for something that was really different than what they had done before?
So it was obviously a big challenge to become a new GEO satellite prime in a market where the requirements are extremely demanding. The only other companies doing this are very large aerospace integrators. So the way we did it was to do a lot of work and essentially on our own account invest a lot of time in the trade-offs, in the designs, in selecting the right approach to build the satellites and to spec it. It was also about finding the right equilibrium between payload innovation and overall innovation with the product line, but without giving up the high reliability requirements that you need to implement in typical geostationary missions. We are building a spacecraft to last for 15 years in geo orbit in very harsh environments and long lifetimes. So no corners can be cut in terms of reliability of the design and of the product. So it was about making also the right make or buy selections. So making sure that we buy those units that go on board the spacecraft that can benefit from heritage and a competitive supplier base, and that we go make those units and subsystems where it's really necessary for us to make them to make the product exist and be competitive. Another key element to success was partnership with the European Space Agency. So the European Space Agency embarked very early on in this adventure with us as a partner and provided an immense amount of expertise and support to our teams, and they still do on the first satellites until they will be successful in orbit. And this has come also with some funding support to some of the non-recurring development activities. And I'd say the combination of all these factors and very good, open, and transparent dialogue with the operators to really understand their problems, to really be transparent about the state of the development of our spacecraft, were the necessary ingredients to create the trust and confidence of all parties that we can do this, and to get everybody committed on this journey.
Absolutely. And you mentioned that the company, you're not just a bus manufacturer, but you're an RF manufacturer and you build the payload technology. So how does having that in-house payload expertise, how does that make you a different type of partner for your customers?
So obviously the payload is ultimately why you put a satellite in space, because the payload pays, we say. It's what deploys the business case for the operator or the end customer. And so making sure that you have cutting edge payload technology, that you really listen to the customer requirements and what is their business case, what is the problem they're trying to solve, and proposing a payload that is best optimized to suit those requirements is at our core, and is really what we drive very actively on every program. Be it if we build a payload for an NGSO satellite, and making sure that that customer gets what they want out of the mission, or if we build a payload for another GEO manufacturer, which we also do, or if we build a payload for our own Hummingsat platform, when we specifically address the small GEO segment of the market. We have differentiating technology for payloads. We rely a lot on additive manufacturing and very advanced RF designs and system implementation concepts that allow us to make payloads more compact, more lightweight, and to get more performance out of them. And getting a denser payload with more performance generated out of a fixed amount of mass and power and footprint on a spacecraft is really are really the key metrics that matter to the business case of the end customers.
How do you think about having payload flexibility?
So payload flexibility is obviously a big thing in the industry, and it's important to have payloads that have some degree of flexibility. But flexibility never comes for free. So if you make a payload that is extremely flexible, it will usually be less performing, and vice versa. And depending on what the customer's business case is, there is a right trade-off to find in between those two extremes. I think, at Swissto12, we build a lot of phased array antenna driven payloads with, onboard digital processing. So we're definitely in the flexible payload space and on the leading edge of that discipline. But not every satellite requires a completely maximal flexibility payload. It's about finding the right trade-off. And especially when you put payloads on smaller satellites, where if a satellite is small and it's fast and it's more affordable to build, and allows for a more incremental approach to deploy capability in space, that is a flexibility of its own before even looking at the payload. So especially in those scenarios, you can afford to have flexible but not completely flexible payloads deployed if there's a cost and speed advantage to doing that. And of course, with the right performance speed net. Then another thing that we shall say is on Hummingsat, we are extremely flexible and accommodating on working with our customers to make sure that we build the best possible payload for their business case. But we also have to maintain a product line and a product line strategy, and to make sure that satellites can be mass produced and produced identically, at least at platform level. So the Hummingsat platform is completely standardized, and we work with our customers to maximize the amount of capability they can get out of the limits that that platform imposes on the mission.
I liked your comment about flexibility isn't free. It's all about those trade-offs. So that's a great point. I want to ask specifically about the Hummingsats that you guys are working on. You're building, I believe, the first one is going to launch for SES, and you're building 3 for Viasat. So, can you give us an update on the Hummingsat program and where the development stands today?
Yes, so we are in the process of completing our design phases for both of these programs. So 2026 will be the year where we conduct our critical design reviews for these 2 programs, but also the year where there will be the full-on ramp-up of the assembly, integration, and test activities for both programs. So it's going to be an extremely busy year, but a lot of progress, and we're very proud to have come to where we are today and excited about the journey ahead towards launching the first satellite in 2027 for SES, and then the next ones will follow shortly after that.
Yeah, 2027. Okay, I know the whole industry will be very excited to see these satellites go up. So space sovereignty has been one of the most important issues over the past year. We heard so much about space sovereignty in 2025, and particularly in Europe, where we're seeing many nations make investments into owning their own satellites. How does Swissto12 and the small GEO concept fit in with enabling these sovereign space type of capabilities?
Well, Hummingsat is a product that is extremely well suited for these sovereign space programs for a number of reasons. First, putting a satellite in GEO is the single most sovereign way of deploying a telecommunication capability in space. Why? Because the satellite's above the sovereign territory that you're trying to cover. You can operate it out of country. You can see it at all times, and you can really make sure that there's no disruption to it, and trust the integrity of the data that you channel through it. Which is not something you can easily achieve with a constellation, for instance, where a constellation is at all times above any point on Earth. And often a constellation is something that is such a big endeavor to build that you need to share it with others to make it financially rational. And as soon as you share something with others, it is fundamentally less sovereign. So GEO plays a key role in satellite sovereignty, and is one of the investments and capabilities that countries and nations make to own a sovereign backbone that it can absolutely trust, and which is usually then complemented with capacity coming from NGSO constellations to create more volume and to offer a diversity of services that makes most sense. But with that GEO backbone that they can rely on or fall back on if necessary. Obviously, we see a lot of countries wanting to own their own sovereign capability. Traditionally, there have only been a very few number of large spacefaring nations who could afford to have their own sovereign satellite, and who would usually then rely on very large, very exquisite GEO satellites that require a significant budget to deploy, and also require a significant amount of requirements and business case to justify. And so you have a lot of smaller, medium-sized countries who either don't necessarily have that full budget or don't yet have the full business case to justify the acquisition of a very large satellite, or who simply have never done a space program before of their own and want to take a more incremental approach to deploying the capability and learn along the journey. And for all of these clients, investing into small geo satellites is a very appealing value proposition because it allows them to take a step-by-step approach. And at Swissto12, we're very happy to work with government customers on their sovereign networks and connectivity solutions. And we're a very collaborative partner who they can rely on and trust to bring such missions to success.
I'm curious, as a European tech founder, do you see the issue of space sovereignty? Is it personal to you in any way?
Well, I think, space sovereignty is important for anybody today on Earth because, we all rely on space in our day-to-day lives, whether it's for positioning or weather or communications, and knowing that there is a sovereign backbone to that is enabled through space, I think should resonate with anybody. And I mean, especially in Europe, of course, there's a lot of space capabilities and space industry in Europe. So there's absolutely no reason why we couldn't do this. And so that's why we're doing it. But it's important to do it in collaboration with others, whether it's in Europe or with partners in the US to bring the capability to reality.
Yeah. I know Swissto12, you recently raised some funding from the European Space Agency and opened a new facility in Madrid last year. So I wanted to ask about how you're expanding manufacturing capabilities and how much the company is scaling up right now. So can you talk a little bit about that manufacturing expansion?
Yes, so the company is growing across all its sectors. Obviously, a lot of expansion going on in our engineering and program and execution teams around Hummingsat, but also around our payload product activities. We have recently expanded significantly our clean room space here in Switzerland with an additional 1,000 square meters of clean room dedicated to the Hummingsat product line, which will really allow us to ramp up our throughput and through that facility exceed 10 satellites in terms of throughput per year when we're fully ramped up. We've also been scaling our presence in Madrid, as you mentioned. Spain is an important hub for us, out of which certain products are being developed, in particular in the domain of payload technologies, and where we have an excellent talent pool and also a lot of industrial partners around us to help scale the business. Yeah, so we're excited to continue on. It's a steep growth journey, but it's a journey that's really driven by customer requirements and customer programs, and a good product market fit that puts us into this good position.
Yeah. Are there challenges as a founder when you're at this moment where your startup is growing up and scaling up in this way?
Oh, there are always challenges, but that's what makes it fun. I think, my job changes almost every day. But that's what makes it tremendously interesting and drives the passion to come in the office the next day for the next adventure. So I would recommend it.
Another issue that is a really hot topic in the news right now is space data centers. Different concepts of what this could look like, whether that's like actual data centers in space or using satellites as a distributed network. But what are your thoughts at this point on maybe the feasibility of space data centers, and if you're thinking about would Swissto12 play a role in this type of architecture in the future?
No, I think it's a very interesting topic, and it's a relevant question to ask ourselves. How far can we push
Hmm.
compute space, and what is the right architecture for the future? I think if you look at it from a distance, building a data center today is something that you do in a real estate facility on the ground, and it has a certain cost to build the facility, but then the facility consumes a lot of operating expenses for electricity, for cooling, that really drives the cost basis of a data center. And if you're in space, once you're there, the energy is for free because the sun gives it to you, and the cooling can also be for free because the universe is cold and you can radiate out the heat. So the real question is, can you make those two financial return curves cross each other in a reasonable amount of time by putting a data center in space, i.e., probably paying a bit more to build the data center and launch it, but then leverage the savings over the lifetime of the assets to make it economically more interesting. And it's as we walk into the future, that crossing point will come nearer and nearer, and will progressively make this choice more rational. But in any case, this market only exists if you have the supporting infrastructure. And the supporting infrastructure is the satellite manufacturing and the space infrastructure building industry. It's the launch segments that's developed enough to support this, but it's also the communication backbone that allows you to integrate an asset like that into a network and exchange high throughput data with the right performance level to make sure that such an infrastructure can be properly integrated into a network. And I think whether it's on the space infrastructure side of this or on the telecommunication backbone of this, it's something we're looking at very carefully, and where we're active in discussions with partners to see how we can support their plans to deploy such a capability, which is really exciting.
Yeah, I think the overall trend there is space becoming a bigger part of the backbone of communication networks. And
Absolutely,
that's where things are going
and
either way.
communication networks becoming integrated across ground and space to create one global network that is best optimized for every use case.
Absolutely. Another future technology I wanted, or emerging technology I wanted to ask about is quantum, because I know that Swissto12, you guys have done a little bit of work there. I saw that you were at Davos recently talking on a space and quantum panel. So, where do you kind of see the outlook for quantum capabilities in space?
I think the quantum capabilities that lie just ahead of us are in the field of quantum key distribution and quantum enabled encryption, where using spacecraft as a relay to distribute quantum keys and enable that next level of encryption security for communications is something that really makes a lot of sense, because I mean, of the inherent security of exchanging an optical quantum key through a satellite, which is extremely difficult to intercept for anybody who would try to do that, but also just the quantum nature of that key exchange that makes it very easy to then detect if somebody has tried to tamper with the signal.
Mm-hmm.
So in that sense, I think there is a big potential to deploy these type of distribution architectures through space, and these would serve well as a sort of synergetic capability to deploying incrementally more connectivity capabilities out of space.
Yeah, very, very interesting stuff. So we are approaching satellite in a few weeks. People will be listening to this podcast in the lead up to satellite. And last year at the show, you won Viasat Satellite Executive of the Year. Congratulations. What feels different for you going into satellite this year, and what are you looking forward to the most?
Well, it was obviously a thrill to win that recognition last year. Um, Although we've now been in this industry for a while, I still feel like a newcomer to a certain extent. I'm a keen
Yeah.
learner, and it's an industry where it's really great to see the amount of change that happens per unit time and how much innovation goes on. So I think having the mindsets of remaining a keen learner is important to succeed in this industry. And so I really look forward to see who's going to win this year. There are plenty of good candidates and people who've put a lot of energy into making impressive achievements out there. And I think for us, it doesn't really change the fact that we need to continue to be super committed to the mission, to our customers, and to developing the capabilities of the industry, and keep the curiosity and the inventiveness high up to be the innovators of tomorrow also.
Yeah. It sounds like Swissto12 is really at an inflection point, and this is a critical year for you. So, at the end of this year, when you look back, what would represent a successful 2026 for you?
That's a good question. Well, obviously, we have a lot of work on our plate to
Yeah.
get our existing programs progressed and have them, well through AIT and securing our launch slot and refining that for 2027. But also, working with new customers, announcing new missions with exciting capabilities, which I'm sure we'll be able to do over the coming months, to make sure that we continue both delivering and innovating in this exciting sector.
Absolutely. Well, I'll be excited to hear about those new missions when you're ready to announce them. Well, thanks, Emile, so much for joining. Do you have any final thoughts as we wrap up?
No, I think this was a great list of questions and topics to cover, and excited to be part of the podcast. And thanks again for the opportunity.
Yeah, thank you so much.